Hello again, it's time for exercise 4, question number 4 on your straight line graphs pack. So let's read the question. The line L1 passes through minus 1, 1 and 6, 15. For L2, that passes through 0, minus 12 and 3, 3. Determine the coordinate of the point at which they intersect. So the plan is work out the equation of both lines, the equations of both lines, and then solve them as simultaneous equations, and that's going to give us the point of intersection. So I'm going to calculate L1 here. I'm going to do the gradient, and that's equal to change in y over change in x. So 15 minus 1 is 14. 6 minus 1 minus 1 is 7. So the gradient is 2. I'm going to do y equals mx plus c, and I'm going to choose the point minus 1, 1. So I've got x, I've got y, and I've got m. So in y equals to mx plus c, I'm going to put that here, mx plus c. Y is 1, m is 2, x is minus 1 plus c, I don't know that. So c, if I solve this equation, is going to be equal to positive 3. So the equation of line 1 is y equals to 2x plus 3. That's L1. Let's do the same for L2, same process. So if you want to pause me and try it yourselves, you can do. I'm going to carry on. So I'm going to do change in y. So minus 12 minus 3 over 0 minus 3. And that's minus 15 over minus 3, which is positive 5. And I'm going to choose the point 3, 3, because that's on line 2. So I'm choosing 3, 3. So I've got x, y, and m. Again, in y equals to mx plus c, I substitute. So y is 3, m is 5, x is 3, plus c, because I don't know what that is. So if my calculations are correct, c is going to be equal to minus 12, if I solve that equation there. So the equation of L2 is y equals 5x minus 12. And now we have reached the point when we can solve these two equations simultaneously. So you guys can see that y is equal to x plus 3. Y is also equal to 5x minus 12. So if y is both these things, then I can make these two things equal between themselves, if that makes sense. So I'm going to do that. So I'm going to say 2x plus 3 equals to 5x minus 12. That's like saying y equals to y, basically. But y equals y doesn't really help. Okay, so let's solve this. I'm going to take 2x on both sides, and 3 is equal to 3x minus 12. I'm going to add 12 to both sides. So 3x equals to 15. And I'm going to divide both sides by 3, and I'm getting that x equals to 5. So that's my x coordinate of the point of intersection. I'm going to substitute in this one, I think, 2x plus y equals to 2x plus 3. That looks like it's got smaller numbers. So I'm going to substitute x equals to 5 in the first one. So y equals to 2 times x. So 2 times 5 plus 3. So y equals to 13, if my calculations are correct. So I need to give this as a coordinate, obviously. The x coordinate is 5, the y coordinate is 13. And this is my final answer. Done.